All right, good morning, class. This video will help us understand how we can tell if an equation has 0 solutions, 1 solution, or infinitely many solutions. And my Apple Pencil is not currently turning on. Let me go ahead and connect it. All right, that should have paired the Bluetooth. Haha, magic, amazing, isn't it? Okay, so we have the equation negative 10k is equal to negative 5k minus 5k. First thing you want to do is just simplify sides of the equation, okay? The left-hand side is already simplified, so I'm going to write that as negative 10k. And the right side simplifies to negative 5k minus 5k. That's equal to negative 10k. Now I want you to observe something. The left side, which is negative 10k, is equal to the right side, which is negative 10k. They essentially have the same slope. Because the left-hand side is equal to the right-hand side, this means for any x value, the equation will always be true. It doesn't matter if you say k equals 10, 7, negative 4, 3.141592628. It doesn't matter. You're going to get the same stuff on the left and on the right. You're going to get equality. So for this specific equation, you have infinite solutions. Any value of k will work. It'll make the equation happy. Let's use a different color now. Let's use green. 2j minus 10 is equal to 9 plus 2j. I want to write it in the form where you have the stuff with the with the variables in the front and then the constants at the end. So the left-hand side is already normalized, right? 2j minus 10. And then instead of 9 plus 2j, I'm going to write this as 2j plus 9, just because I like things to match up. I like order. Notice how they both have a 2j, so they have the same slope, but notice how they have a different starting, I did not spell that word correctly, different starting value. So even if you were to subtract, for example, the 2j's from both sides, you're going to get the equation negative 10 is equal to 9. Does this mean you have 0 solutions or infinitely many? If you said 0 solutions, you're absolutely correct. Again, no value, let me write that down, no value for j in this case, for j will make this equation be true. And that comes from the fact, you can think of these as linear equations, right? 2x minus 10, or 9 plus 2x. There's no specific value where the equations are equal at the same time. Eight minus 10f is equal to 8 minus 7f. Again, I like having my variables in the beginning, so I'm going to go ahead and switch the order here. So that's going to be a negative 10f plus 8 is equal to negative 7f plus 8. So, do they have the same slope or different slope, right? That's the number in front of the variable. They have different slope, and they also have the same starting value, which is redundant. That means it actually doesn't matter. Because they have a different slope, they're growing at different rates, right? One might be growing like this, The other one might be growing like this. They're traveling at different speeds. But notice, if they have different rates or different speeds, one will catch up with the other eventually. Thus, this equation has a solution. In fact, it only has one solution. And a really easy way to tell is, are the numbers in front of the variables different? If they are, only one solution. Let me write that down. If the numbers in front of the variable are different, you will have one solution. Negative 5z plus 2 minus 15z is equal to negative 6 minus 20z. This looks a bit complicated. Now, most of us would probably start saying something along the lines of like, wait, there's different numbers in front of the variables. This has one solution. But it doesn't work like that. You have to combine like terms on the left-hand side and the right-hand side. We have z's here, and that adds up to negative 20z, and then plus 2 is equal to negative 20z minus 6. Again, I switched the order because I like having my variables in the front. So what do you identify here? They have the same slope, right? Same number in front of the variable, and they have different starting values. Visually speaking, this means you have two lines that start at different places, right? I'm just putting random numbers here, but they're growing at the same rate. And if you have two people who start in a race at different spots, but they're running at exactly the same speed, are they ever going to catch up to each other? No. They're always going to be the same distance apart. Unless somebody throws a dodgeball at one of their faces and they fall down, right? At least the person in the front. So for this specific example, they have the same slope, different starting values, or different constants. So this is going to have no solution. There is no specific z value here that makes both of these equations true. Ooh, this one looks fun. There's parentheses involved, so what are we gonna have to do? Multiply, right? Also known as distribute. Negative 2 times negative 6k is positive 12k. Negative 2 times positive 11 is minus 22. Minus 17 is equal to 12k. Negative 22 minus 17, this is a negative and you're taking away a positive, okay? So you're making it more negative. That's gonna be a negative 39. Let me write that k better. 12k minus 39 is equal to 12k. Immediately, you might be able to see they have the same slope, but different starting value. And a lot of you might want to say this has no solution. Well, let's look at this algebraically, okay? Because I feel like a lot of you are kind of like, okay, I can use these little, conditions to define if something has 1, 0, or infinitely many solutions. So again, remember, if you're trying to solve for a variable, you're trying to isolate it or get it by itself. So I'm going to take away 12k from both sides to keep the equation balanced. That's a 0. That's a 0. I'm left with negative 39 is equal to 0. Immediately, you should be like, bro, that's false. Because it's false. It's a false statement, which means it doesn't matter what value of